All right, and we're back at it again for another video in our series of how to go from zero to hero in Cadence development. And this is going to be kind of a different video because instead of actually going over like syntax or individual Cadence concepts, we're actually going to take everything that we've learned so far and make our own NFT. And I wanted to do this because most people have been saying to me, just get to the NFT, get to the NFT. And that's because there's an NFT craze going on right now, and most people are really interested in it. So why not? So we're gonna make our own NFT called Crypto Poop, and so we're gonna have a contract that actually mints and gives people crypto poops. So this is going to be our sort of own NFT that we're going to be creating, and we're doing this completely from scratch. And so this might be sort of on the longer end of a video, but let's walk through it. So like I said, we're going to take everything we've learned so far, and one of the things that we've seen so far is something called a resource. And a resource, like I was saying in previous videos, is so important when it comes to Cadence because it allows you to store something that's completely unique, right? Every resource in Cadence is completely unique. You can't copy them, you can't move them without putting them somewhere else or destroying them. And so they're perfect representations of NFTs, and the Flow team actually built resources, sort of for that ability. And so we're actually going to represent our NFT as a resource. And so let's actually do that. So we're going to have a resource called NFT, and we're just going to add a simple init here. And so usually, NFTs, or not usually, always, NFTs are completely unique. And so that's helpful because, NFTs are represented as resources in this case, and every resource is unique, but we're going to ensure uniqueness. And the way that we're going to do that is we're actually going to add a ID field, and we're going to make it a UN64. And so what this is going to do is we're going to make sure that every time we create an NFT, so inside the init function, we're actually going to give it an ID. And so what do we want to give the ID to make sure that it's unique? Well, we can have at the contract level a public var total supply. So a total supply, I can't spell, and this is going to be a UN64. And so what we can do is we can say, hey, we want our NFT to be, CryptoPoops dot total supply. And then what we'll do is we'll just increment the total supply by 1. So equals CryptoPoops dot total supply plus, and we're just going to do 1 as UN64. This 1 is an integer, and so I'm just saying as UN64. And so by doing this, we're going to make sure that, hey, every time an NFT is created, it gets its own ID, and then we increment the total supply. And so it's complaining because we haven't initialized it in the contract, and so let's actually do that now. That total supply equals 0. Okay, and so this is, again, because resources are all unique, this isn't totally necessary, but it's helpful so that we can read the ID field very easily. So now we actually have our own NFT. So let's actually create a function, public function create NFT. And what this is going to do is this is going to create and return a NFT resource. And I want to mention that if you're ever confused by any of the syntax in the video, go back to previous videos because everything I'm showing you here, we've already gone over in previous videos. So this is, resources, this is, creation of resources, all this has been previously explained. So what we're going to do is we're going to return a NFT resource, and there's nothing in the initializer, so we don't have to put anything here. And again, the reason we're making this function is because you can only create resources using the create keyword inside the contract, and so in our transaction we can't just say like create NFT. So we actually have to have a function that's publicly callable to create it. And so here we go. So now we have a contract that creates a NFT, and it also returns a NFT. So let's deploy this, and we'll see that it is deployed. And then in our transaction, we're actually going to import hello world, or this should be actually crypto poops from OX01, and inside of here we're going to say, okay, we're going to log stored an NFT. Okay. There's an extra parentheses there. And then inside this prepare, we're actually going to store an NFT inside of our account storage. So account.save. And this is going to be a, inside here, we're going to move a CryptoPoops create NFT, and this will return an NFT and then move it into account storage. And we're going to store this at /storage/ my CryptoPoop. All right. And before we do this, let's actually create a script. Actually, so this is okay. So we'll do this, and then what we can do is, yeah. So let's do this first. So let's sign this with account OX01, and it says stored in NFT, right? Cool. So we've stored an NFT, and let's actually make another transaction to borrow that borrow that NFT. So let's just copy and paste this code. And put it here, and instead of saving in this one, we're going to .borrow from /storage/my crypto poop, and in this case we actually have to specify the types. This is going to be a reference to a crypto poop NFT. Okay, and let's just force unwrap the operator. So let's say let reference equals account.borrow. What's crypto poop? Crypto poops. Okay, cool. So what we're doing here is we're just going to say we're just going to name this to a reference equals account. We're borrowing the crypto poop NFT reference from our storage, and instead of actually doing this, let's just add a panic in case this doesn't work. Just say, hey, we're going to panic and say nothing exists here. You don't have an NFT. All right. And then after we get the reference, we're going to say log a reference.id. All right, so let's clear our console, and we're going to send this transaction, and boom, we can see that we got the ID of 0, and it says stored. Oh, it shouldn't. This should say like printed NFT ID. Okay, cool. Now, what would happen? I'm sure you can all guess, but what would happen if I ran this with account 2? Let's try it. Let's clear the console and send it, and we'll see it says nothing exists here. You don't have an NFT, and that's because we didn't store anything, right? So if we were to go back to this transaction, run this with account 2, we stored it, and now if we were to go back to this transaction, run it again, it would say 1, right? And that's because of the fact that every time we're creating an NFT, it's incrementing the total supply, and so bam, we are good to go. Now I want to see if any of you have see a problem with what we've done here. The problem is that if, let's say we want another NFT, right, from this contract, what's going to happen in this example? Remember I said that in account storage, you can only store one thing there, right? So if we were to run this with account 1 again, what's going to happen? Error. Object already exists here. And so this is a problem with account storage, but there's actually a way to fix this. And the way to fix that is with something called a collection. So in NFT contracts, you're always going to see something called the collection, and I will show that to you now. And so we're going to create another resource called collection. And what this is going to be is a container for your NFTs. And so instead of storing an NFT in your account storage, we're going to store a collection and then put NFTs in that collection. That way it all exists at one path. And it's easy for people to read the IDs that we own. We can withdraw and deposit into the collection. That's all stuff we're going to do now. So let's actually do that now. And so inside of here, I'm going to actually do public var owned NFTs, and this is going to be a mapping from a uint64 to a actual NFT resource. And so we have to put our little symbol here because if a dictionary contains resources, we put on the outside, and we're going to say init, and we're going to initialize self.owned NFTs. We're going to move an empty dictionary into it. Okay, so we've done that. And as I explained in previous videos, if you have a resource that contains other resources, you have to actually specify a destroy function, or else it will complain, and that you just say destroy self.owned NFT, so that when we destroy the collection, it destroys all the things inside of it, blah, blah, blah. All right, so we are now here. Awesome. So what we can do is we can actually, specify a public function deposit. And before I do this, it might be confusing what this means. So this is going to map the ID of the NFT to the NFT with that ID. So for example, we would map an NFT with ID 0 to that actual resource, right? So it's being stored inside of there. So what we can do is we can actually deposit. Let's call it a token, and this is going to be a NFT resource. And we're going to open this up. All right, and so inside of here, it's going to complain loss of resource. We actually have to put this token somewhere, and so let's actually do that together. So let's say self.owned NFTs. We're going to force move the token into it, and we're going to move it in at the token.id. All right, and so this is what we've done. So if we wanted to put an NFT into a collection, we could totally do that here, and it's going to put the token inside the dictionary here, right? And so I'm looking at my notes over here just to make sure I haven't missed anything, and it looks like we are good to go. All right. So next we're going to do a public function withdraw function, and this is going to take in the ID of the NFT that we want to withdraw, and it's going to return that NFT resource. And so in here, what we can say is we can say, hey, let the token be, let's say, self.owned NFTs at the ID, right? Oh, it's going to say cannot move nested resource, and that's because, so we actually have to do this like a little bit different. We actually have to say self.owned NFTs dot remove. This is sort of like a little, this is like a thing in Cadence where, you actually, let's just return the resource so that I don't get these errors and just make sure I'm doing everything okay. So when you're dealing with nested resources, which means you have like a resource inside of another resource, in this case NFTs inside of a collection, you actually can't just say like owned NFTs like at ID, because you can't move nested resources like that out of a dictionary. You actually have to say like the dot remove method and you specify the key. It's just a little thing in Cadence, and this is an optional type, and so the way I fixed that was putting, the force unwrap, but of course we could also put a panic and just say like that like this collection doesn't contain NFT with that, with that ID. So just a way to, tell Cadence that, hey, this is what you do if that doesn't exist. And then we're going to simply, actually return that back to the person who wants it. All right. So that's what we've done. Cool. Besides that, what else are we going to want to add? Let's add a function called public function get IDs. And so this is going to be a function that just returns a list of an array of UN64s. And this is just going to return self.owned NFTs.keys. So this is just going to return all of the IDs of the NFTs we have in our collection. That is all cool. And all right, so this is what we're going to do. And actually, yeah, so let's stick with this for now. So all we've done is specify a collection where we can, store NFTs inside of it, and this is because of that account storage problem, right? And so everything is kind of contained in one little wrapper, so it's really easy for us to understand. Okay, so let's redeploy this contract. If the playground isn't buggy, it will be nice to me. Okay, great, it was nice to me. So we're gonna revamp these transactions a little bit. Oh, I forgot to do one thing. You might have been saying, well, how the heck are we actually going to, create a collection? And you'd be right. So public function create collection, right? Because the user has to get a way to actually like have this collection. And we're going to return create collection, and now we can actually deploy this contract and be happy. Create NFT. Oh, I think it's just being buggy. Hold on one sec. I think it's just being buggy. Oh, I must have missed something. Oh, yep, I missed that. Okay, cool. So let's redeploy. It's deployed. And now what we're going to do is we're actually going to create a collection. So we're going to do create collection. And we're going to store this at /storage/collection. So this is where we're going to actually store a collection. And we're going to say stored a collection for our crypto poops. All right, let's run this. So bam, stored a collection for our crypto poops. Cool. So what we're then going to do is we're going to actually add a script, and so this script is going to import crypto poops from from OX01, and we're going to return a list of UN64s. And so if you may have guessed, we're going to return a list of our NFTs inside of our collection. And so in order to actually access our collection in a script, we have to have like a public reference to it, right? Or else this wouldn't work, because you can't borrow directly from account storage in a script. And so we need a way to publicly allow someone to read the IDs of our collection. And if you think about how you want users to interact with this collection, you don't want other people to withdraw from your collection. So what I mean by that is if we were to simply do this, account.link, and we were to link our CryptoPoops.collection, and we were to say, hey, we want this to be at /public/collection, and then the thing that we're linking to is actually /storage/collection. If we were to do this, then what do you think would happen, right? In our script, we could actually get a capability to that, right? Because this is creating capability, and if you don't understand that, make sure to watch the account storage and capabilities video. But if we were to do this, then inside of our script, anyone could just use this reference to withdraw NFTs from our collection. So that's not what we want. But we can use something called a resource interface, and I also made a video on this if you're confused about what this is. But we'll call this collection public. And so inside of this resource interface, we're actually going to link the get IDs function to the public. And so what we can do is say, hey, we want our collection to actually implement the collection public resource interface, so that anyone can read the IDs of our collection. So we can actually redeploy this again. We're going to probably redeploy 1 billion times in this video. And now what we can do is we can say, hey, we don't want to link the whole reference, but we just want to link CryptoPoops.collection public. And so now the public, because we've linked this as a public collection, anyone can actually call that get IDs function on this thing. And if I refresh, I think it's just being buggy. Yep. So we can do this again. So let us send this, stored a collection for our CryptoPoops. And then inside our script, we can actually say, okay, let's take in an account. This is going to be an address. And let's read the IDs of that account. So let public reference equals let's first get the account with account, and we're going to get the capability. So get capability to /public/collection. And again, this is because inside of our transaction we linked it to the public right here. It's /public/collection, and then we're going to borrow this, so dot borrow, and we're borrowing a reference to CryptoPoops.collection. There's a lot here, CryptoPoops.collection public. Okay, so that's what we're borrowing. And then if we can't borrow, we will add a panic that says, hey, this account does not have a collection. All right. And so I think it's complaining. This should be fine. Oh, because I forgot to add a closing thing here, and it's saying missing return statement. So then what we're going to return is return public reference dot get IDs. And now we can actually put our thing in here. So let's actually run this this transaction first. So we're going to give a collection to, let's say, account 0x01. Send that. This is already source an object, so let's just use a different account. Let's just use account 4. So we're going to send this. It's stored a collection for our CryptoPoops, and then inside our script we're gonna put OXO4, and if we execute this, we'll see that there is nothing in our values array because we haven't put any NFTs in our collection. So I'm gonna name this to create collection. Okay, and then in this one I'm gonna say deposit NFT. And so in this one, we're going to deposit an NFT to our collection. So let's do that here. So let us get a reference to collection. And this is going to account.borrow a CryptoPoops.collection from storage /collection. And if we say nothing exists here, you don't have a collection. So we're going to go to an account, we're going to borrow a reference to their collection and account storage, and we're going to actually call the deposit function. And remember, we can call deposit because we are the owner, right? We're using the auth account. So this isn't like a public capability, this is directly from storage. So what we can say is we can say a reference to collection dot deposit, and the token that we want to put in is a newly minted NFT. So we're going to say CryptoPoops.create NFT. And so we're going to store a NFT inside the collection. So we're going to say This is going to say stored newly minted NFT into collection. Okay, so let's clear a console. Let's run this. Stored a newly minted NFT into our collection, and now if we were to read the IDs from account 4, we would see that now, oh look, it has 0 in it. And so, remember back to the original problem, we want to store multiple NFTs. So we could run this as many times as we want. Bam, stored newly minted NFT, stored another one. Let's store another one. And then inside our script, if we clear this, you'll see that, look, we actually have 0, we have 1, we have 2. You can see this, right? Yeah. So we have a bunch of NFTs now in our collection, and so that's why having a collection is so useful. All right. So I think I'm going to conclude the video there because this is sort of how to set up a base NFT. In the next video, I'm going to go over how to actually, actually, should I do this now? Let's do it now. Okay, let's do it now. So I was going to actually say that to the next video, but I think I'm actually going to make this video like a 40 long minute video of just how to do NFTs, and that's it. So I'm just going to do this in one video. Okay, so I was trying to convince myself not to do that, but here we are. All right, so this is where we are. Okay. So the next problem is that we don't want everyone to be able to mint NFTs. Okay, so before I keep going on, if you're bored, you can take a break here. That was a lot, but if you want to keep going, feel free to keep going. Okay, so the problem now is that so anyone can mint an NFT, right? And we don't want that to happen. If I have a collection that's super rare, why should anyone be able to mint a Bored Ape, right? I could just go and mint a Bored Ape if I wanted to, right? That shouldn't happen. It should be someone controlling that minting process. And so instead of just having this ability to create NFT be public, let's actually create a resource called NFT Minter. And what this is going to be is a person that if they own this resource, they can mint NFTs. And so we're going to add the function in here. So take this function and put it inside our minter. And if we do this, let me try and get this spacing right. Now, no one can call create NFT unless they actually have the minter resource. And so we're going to put a init in here like this. Okay, cool. And so, there's no way to actually no one actually has this resource, right? Because we can only create this resource in the contract. And so what we're going to do is we're just going to store this minter resource to the account storage for like the contract storage, so that this account 0x01 is like acting as the admin. So we can actually do that in here in the init function of the contract and say self.account.save. We're going to save a create NFT minter, and the path is going to be /storage/minter. All right, and so what we've done is we've actually made it so that only the account has this minter, only the 0x01 account has this minter. And so if we were to deploy this contract again, here we are. Cool. So we've done it. Now we can actually go to deposit NFT, and remember there's a problem with this, right? If I was to refresh this page, you'll see that, hey, this no longer exists, right? You can't just create an NFT like that. And so what we actually want to do is we want to make it so that a minter deposits a NFT into the user's collection. And so we can do that actually by making because we want the minter to sign that transaction. We want the minter to say, hey, I want to give this person an NFT. And so in order to do that, the minter will have to have access to that person's collection to deposit. And so let's actually make it so that in here we expose deposit, which is going to be a token at NFT. And this is going to, so this is it. So now deposit is able to be called by anybody. And, there are some design decisions around this. You might want it so that not everyone can deposit into your collection. But on Flow, typically you expose deposit to the public, because the truth is, while it may be annoying to have crap NFTs in our collection because anyone can deposit, it's not bad to have NFTs in our collection because they're valuable, right? But of course, we would never want to expose withdraw. But we'll just do deposit for now so that a minter can actually deposit into the collection. Okay. And that's usually typical behavior on Flow. So you'll see that a lot where deposit is publicly available. So the person that's actually going to be calling this transaction now, so the minter, so the NFT minter will sign this transaction. And so we essentially need it so that we're actually going to just start from square one here. So we'll start from square one. So the minter is going to first get the minter from their storage, mint an NFT, and then deposit it into the publicly available collection. So let's do that. But we also have to, put in a recipient address because this is the person that we're going to deposit into. Okay, so first let's get the NFT minter. And this is going to be, account.borrow /storage /minter. And this is going to be a reference to a cryptopoops.nft minter. All right. So here is the thing. And so we're just going to say, hey, do that in case we can't, borrow it. So then what we're going to do is we're going to say let, we're actually going to get this from here, right? Because we've already kind of written this. So this is a public reference, and this is going to be the recipient. So this is getting the recipient's public capability to their collection. Just like we did in the script. And so this way we can actually deposit into their account. And so let's actually do that. So let us say public reference dot deposit, and then token is going to be a NFT minter dot create NFT. And we're going to move it into here, right? Deposit. Oh, and I think it might be saying that because did I not redeploy the contract? Okay, yeah, no. So let's walk through this, right? So we got the NFT minter from the NFT minter that's signing the transaction just from their storage. We got the public reference to the recipient's collection, and we're allowed to deposit because we put that inside the collection public, right? And so then we're going to say NFT minter, create NFT, and that's calling this function right here. And then we're going to deposit it into the collection. So let's do that. So we want to create a collection, and let's do it for account, let's say account 2. Bam. And just to make sure, account 2 has nothing inside of their collection, right? Nothing. But what we can do is go to deposit NFT. We can say the recipient we want to be account 2, but we're going to sign it from account 1. And the reason we have to sign it from account 1 is because, remember, we store the NFT minter inside of account 1, right, in the contract. So let's actually do that right now. Right, let's sign this transaction. Sign this. Stored a newly minted NFT. We can even do another one if we want. And then go back to our script and read account 2. And bam, we now have 2 NFTs inside of our collection. So this explains how to actually make it so that a minter is handling the minting capabilities of our contract. So awesome. Okay. Now, again, if you want to pause the video there and take a break, you can do that, but I'm just going to keep going. So I'm just going to do everything in this one video. But this part may get a little confusing. So I hope I don't completely throw everybody off. But I'm going to just keep going. So there's one more concept when talking about NFTs, right? If we wanted to make our own NFT contract, this is perfectly fine. We've done it. We've made NFTs that are stored in a collection. You can deposit, you can withdraw, you can do everything. You could even transfer, right? You could take an NFT from one account, and let's actually do that together. So transfer NFT. So this is going to take an NFT from one person's collection and give it to someone else. So let's actually do that together. So let's just copy and paste this transaction code just because I don't want to have to do it all over again. So the person signing is going to be the giver of the NFT, and the recipient is going to be the person we're giving the NFT to. So let's put in this log, we transfer NFT, and we're going to get rid of this and get rid of this. And we're going to actually get we have to withdraw from this account's collection. And in order to withdraw, we need from account storage, so it needs to be an auth account. So let's say let collection equals account dot borrow from /storage /collection. We're going to borrow a cryptopoops dot collection, right? The whole reference, it's not restricted by an interface because it's fine. And so now we have access to their whole collection so we can withdraw from it, and we still have access to the recipient's public collection so we can deposit, right? So let's actually go in here and say public reference dot deposit, and the token we're going to deposit is collection dot withdraw ID and then ID. And so, of course, we actually have to pass in like an ID to withdraw from. Okay. And let's just put this there. Okay, so we unwrap the optional and we're good to go. So let's go to our script and let's see that right now account 2, actually, if I clear the console, account, why is it doing that? Okay, so account 2 has two things here, and if you can't read that, I know it may be small, but this just says 0 and 1. Okay, so account 2 has 2 NFTs right now with ID 0 and 1. And so what we're actually going to do is set up the third account. So we're going to transfer from account 2 to account 3. So let's set this up. We've created a collection, and so we're going to go to our script and read for account 3. And so account 3, we can see has nothing in there. So there's nothing. What we're going to do is we're going to transfer. So the signer is going to be account 2. They're the one giving. The recipient's going to be account 3, and we're going to give away, let's say, ID of 0. So if we were to send this transaction, it says transfer NFT, and we can go to our script, see that account 2 now has just the ID with 1, and account 3, if we were to clear this again, actually has the NFT with ID 0. So that's how to transfer an NFT using collections, and so that's also why collections are super useful. Okay, bam. Now, there's one more important thing, and this may take another 10 or so minutes, so if you're bored by me, which is totally reasonable, you can take a break. But in this next section, we're going to talk about how to actually make it so that our NFTs are NFT compatible. And so what I mean by that is, for example, in Ethereum, you don't have to know anything about Ethereum, but I'm just going to, for those of you that do, something like ERC 721 or ERC 1155, and these are NFT standards that a NFT must, implement in order to, actually be tradable on things like OpenSea, right? So if we were to go to like OpenSea right now, OpenSea is a NFT marketplace, and all of the NFTs that are on this marketplace, all of the ones you'll see here, so we can actually go to like a resources, or what can we just look up like a turtle? Let's just find a turtle. So all of these NFTs you see here, these are all abiding by a spec or a standard. And the reason for that is because, OpenSea wants to make sure that no one's uploading like scams, right? Or something like that. And so on Flow, there's a similar concept. And so there actually is an NFT standard. And so in order to do that, let's actually go to on Flow, or let's actually look up NFT standard on Flow. And it's actually a GitHub repository. And you can go to contracts and then nonfungibletoken.cdc. And so we're going to copy and paste this and walk through it together. And I'll explain exactly what this means. So we're going to go to a new account. We're going to deploy it inside of this account. And we're going to deploy. And so let's actually walk through what this even is. So the non-fungible token standard, there's a bunch of comments here. But essentially, it's a contract interface. And so, I've already gone through resource interfaces. And a resource interface, like we've shown, is a way to say, hey, if a resource implements this resource interface, it must have this, right? And so, for example, this resource interface, collection public, says, hey, collection, because it implements it, must have a deposit and get ID. So if we were to like delete this, it's an error, right? Resource crypto poops collection does not conform to the resource interface, okay? A contract interface is the exact same. So it says, hey, any contract, right? So at the contract level that implements non-fungible token must have a total supply. It must have this event. It must have this NFT. It must have a collection. And so I've actually sneakily in this video been making this NFT based on the standards that it's not too much changing. So what we can do is actually make our NFTs fit the standard, right? If they want to be tradable on things like OpenSea, which doesn't exist yet, but in the future, we would have to import non-fungible token from 0x02 and say, hey, our crypto poops is a non-fungible token. And so a bunch of errors are going to pop up because we haven't actually done this yet. But we need to now make our contract, actually fit the standard. And so let's walk through this one by one to see if we need it, right? So first of all, total supply, we already have that. An event. So we should take this event because we need it. Let's actually, put this into our contract, and this is when the contract is initialized. So let's scroll down and actually say, hey, emit contract initialized. So boom, we've tackled that problem. The next one is a withdraw and deposit. So let's actually take both of those as well. So let's take these. Let's paste these inside of our, inside of our contract. And so this is when we withdraw and deposit NFTs from our collection. And so, we're actually going to walk through that in a second here. But let's just leave those there for now. What else do we need? Let's see. So here's one thing. So this is saying this is a resource interface called INFT. Now, one sort of trick about contract interfaces is that your contract that implements it doesn't have to have the resource interface. So we don't have to copy and paste this over because it's a resource interface, so we don't have to exactly replicate it. What we do have to exactly replicate is the resource itself. And you'll see that it says, hey, you need a resource called NFT, okay? And we already have that implements INFT, and INFT is this right here. So what we have to do is say, hey, look, it's giving us an error. It says this is missing a declaration to required conformance to the resource interface non-fungible token.inft. So we actually have to say, hey, we want this to fit the non-fungible token.inft. And so now we no longer get that error. And the reason that this is fine is because if we go back to this contract, it says, it says, where is it? Here. It says that the INFT resource interface just makes sure that you have an ID, and we already put the ID in there, so it's totally fine. And we also, like I said, we have a resource called NFT already with an ID field in it, so we are good to go. All right, boom. So the next couple of things are all resource interfaces. So we actually don't even need to have any of these. We don't need to copy and paste them because they're, again, the resource interfaces. But these explain ways that we can actually make our collection, available to other people. And so in this standard, it says there's a collection resource that has a provider, a receiver, and a collection public. So the provider exposes withdraw. But remember, you would never link this to the public because you don't want people to withdraw. A deposit, which you probably should link to the public, and then a collection public, which obviously you should as well, which contains deposit anyway. So it's kind of like repetitive, but you get the point. And so this standard is saying, hey, we need a collection called collection that implements these three. And so let's actually go back to our thing here, and it's saying, hey, look, it's missing a declaration to all these things, right? And so we actually have to add those here. So non-fungible token dot provider, non-fungible token dot receiver, and non-fungible token dot collection public, right? So it's a lot. And of course we're going to maintain ours, although this is sort of repetitive, so we actually don't even really need this anymore. And so let's just delete our version of collection public. And so, of course, now we get a bunch of errors because, we have to make sure that what we're doing is actually fitting these three resource interfaces. So let's go back to our standard. And it says, hey, let's actually look at what this is doing. So it's saying that our, collection must have a owned NFTs that has type NFT. Now, this is tricky because this NFT is referring to the NFT that exists in this contract. So this NFT. And so if we go back, we actually have to say this isn't, our owned NFTs isn't a, the NFT we've defined here. It's the one in the standard. And so this is going to be non-fungible token.nft. And so this gets a little tricky now because, it's basically saying that this resource is basically any NFT that abides by the NFT standard. Okay. All right. So what is the next thing that it's complaining about? So let's actually go back and look at our standard, and look what it is saying here. So right here, the same thing happens for deposit, right? It's saying when we deposit, we're going to deposit an NFT resource, but again, that's the NFT that's defined in this contract. And so when we go back to ours, deposit is going to be a non-fungible token.nft. Okay. So that fits that one. And same with withdraw, right? Withdraw is also has to be a non-fungible token.nft because that's what it specifies. All right. So let's see what collection is complaining about. It says does not conform to requirement non-fungible token collection public. And so if we go down to the resource interface, we can actually see that collection public specifies we must have a deposit. We've already done that one. Must have a get IDs. We've already done that one. And the last one is it must have a borrow NFT that returns a reference to a non-fungible token. So we can actually we can take this directly, copy and paste this, and bring it back into our collection. And let's add that here. Now let's actually open up this function. And what we're going to do is, hey, we're going to say, you know what, let's just return a reference to self.owned NFTs at ID. And then you have to say as a, reference to a non-fungible token.nft. And same thing with here, right? This has to be non-fungible token.nft. All right, so we've implemented borrow NFT. Now let's see what else we're getting here. So CryptoPoops does not conform to requirement resource interface provider. So let's see what provider is saying. Provider says, hey, so we're going to put in, so this is another thing. So provider says that it's a withdraw function and the parameter name is withdraw ID. So that's why it's complaining. So we actually, in our withdraw function, we change ID to withdraw ID. And so these are just little things that the standard requires. So now now our collection fully fits the standard. And so we've done it. Now, what else? What's the problem here? So of course it's just giving like a very stupid error. I don't know. We'll have to look and see what exactly we're missing in order to fit the standard. So it looks like, this is what we're missing. So we're missing a function called create empty collection that returns a collection. Now we've actually done this together. So but we actually have to name it the exact same thing. So create empty collection, and this returns a collection, and boom. Our contract now fits the standard. So everything that we just did is now good to go. We've completely fit the standard. Boom. Which is, really, really, really awesome. So we can actually deploy our contract. And if we wanted to, we could now take, it's going to give errors, of course, but let's refresh the page. Let's try and deploy again. It's because we have to deploy non-fungible token first, right? So deploy this one first. It's deployed now because this one imports it. We can actually deploy this one, and let's see. And it's deployed. So we just officially made an NFT contract that can be out there in the public. These crypto poops could now be, bought and sold and listed on OpenSea. That's it. We now have an NFT that fits the standard, which is super cool. Now, so that is that section of the video, and now I do want to add one more thing that I do want to say. So yes. So this is all good. And if we were to actually walk through the steps, you would see that it's exactly the same. It just now fits the standard. But there's one sort of thing here, right? So the problem is that our NFTs right now, if we want to read something about the NFT, so let's say we have an NFT in this collection, and let's say we wanted to add to our NFT a public let name, right? So this is going to be a string, and we'll just say, hey, self.name equals Jacob is the best. So that's the name of this NFT. And of course, this is going to be the name for every single one of the NFTs. So it's a little, stupid, but whatever. So that's actually, you know what? Yeah, so let's leave it at that. Okay. So, but the problem now is think about what this means, right? So inside of our collection, if we wanted to, before we did all these changes, if we wanted to read something about the NFT, we would have to withdraw it, right? Well, now we have something called borrow NFT. And what borrow NFT is doing is it's saying, hey, just give us a reference to the NFT. So we don't have to withdraw the NFT. It can stay in our collection. We're just going to return a reference to it. But look what's happening. It's returning a reference to a non-fungible token.nft. And non-fungible token.nft, if we look inside the contract, only has an ID field. So if we wanted to, read the name of our NFT, we couldn't do that using this, and I'll show you. I'll show you why. So, of course I gotta rename this to create NFT collection, and this is going to be. Oh, and so let's actually walk through. Let's walk through this now. So, if we wanted to create an NFT collection, um, this no longer exists because we deleted CryptoPoops.collection public, right? Our collection now abides to these three. And so we can actually say, no, instead, we want to make that, non-fungible token.collection public from O2. So non-fungible token.collection public. And again, non-fungible token.collection public has, let's actually look at it, here. So deposit, get IDs, and borrow NFTs. So that's exactly what we need. So let's do this for account, let's say 2. Oh, it's being glitchy. Hold on. I have to refresh and add a N here. So let's do this for account 2. So it now has a collection. And let's deposit an NFT. This is the same thing. We have to add this here. So non-fungible token. Okay. And so we're going to deposit into account 2 using the NFT minter, which is in account 1, remember. So let's clear this and mint. It's being glitchy again. The playground is amazing. Okay, so let's just refill this in. Send this. Bam. We stored a newly minted NFT into our collection. So if we, in our script, let's say we wanted to, we have to do the same thing here. Copy and paste this. All right. Let's get the IDs of account 2. We'll see that it is right here. If you can't see it, this says 0, so we have 0. But let's say we also wanted to, while we're doing this, let's log public reference. Let's actually just make a whole new script because that might make more sense. So this is going to be a script to read name. Let's copy and paste this. And instead of returning the IDs, we're going to return a string, which is the name of our NFT. So this is going to be borrow NFT at ID. So we also have to pass in the ID we want to read from, right? This is a UN64. And we're going to say dot name. So look what it's saying, right? So we get the public reference to the collection. We borrow NFT with this ID. And if we go in here, we see that borrow NFT is returning a reference to a non-fungible token at NFT. And this isn't possible, right? Because it says value of type non-fungible token.nft has no member name. And remember, that's because this in the NFT standard doesn't have a name field. So how do we go about that? Well, you add a function called borrow. I like to call it borrow like entire NFT so we can read all of the things about it. And so in this, what we can actually do is, hold on, I'm just checking my notes here to make sure I'm doing this right. Of course, I might not be able to, but hopefully I'll be able to do this. So we're going to return a reference to our NFT that we've defined. So this is, including the name field, right? So how you do this is you say, hey, let's get a let reference to an NFT equals this. So we're first going to get the reference to this thing right here. And remember, this has a type of non-fungible token. But we're going to put a keyword called auth. And what auth means is we can actually take this reference and downcast it to our NFT. So remember, this is implementing an INFT. We're going to take that and actually downcast it to our NFT. And so we can do that by saying, hey, we have a reference to a non-fungible token. Let's actually return ref NFT as, so downcast it to a reference to NFT. I believe that works. Okay, perfect. And so what we've done is we've said, hey, let's get a reference to the NFT with the auth keyword so we can actually downcast it using as to our NFT. And so now we can read the name field if I'm not mistaken. So let's deploy this. Oh, I probably have to redeploy this one too. So let's deploy this one. Let's deploy this one and go back to our script. So if I was to, let's try and do this again. So borrow entire NFT. Member is not accessible. Oh, I have to refresh the page. Oh, of course, it's because I forgot to include this borrow entire NFT inside of our collection public. And so I kind of screwed up because I deleted this earlier, but public resource interface, my collection public. And so in here, I messed up earlier. I should have done this. I shouldn't have removed this, but we're just going to take everything that would normally be in a collection public, and we're going to put that inside of here. And then we're going to add public or pub fund borrow entire NFT. So this is going to be ID, UN64, and this returns a reference to NFT. And remember, this one is actually, non-fungible token.nft. Okay, and then we have to add this resource interface here. So my collection public does not conform. So why does this not conform? Oh, because this also has to be non-fungible token. Okay, so I apologize for having to do all this annoying stuff just to show you one thing. But let's redeploy this one. Let's redeploy this one. Okay. So now we're going to do, we actually have to also add this link, the new link now, right? So cryptopoops dot my collection public. All right. So now we can actually do this, and let's try and do it. So let's refresh the page. Account.link. So we're linking, let's do a new collection that has the ability to read the entire NFT now. Let's deposit some NFTs into here. So let's deposit some NFTs, let's deposit another one. And let's actually read the name now. So let's see if we can do this. All right. So let's change this to cryptopoops dot, my collection public. So my collection public. And let's read the name. So account is 02, and the ID of the NFT, let's say 0. And let's run this. And boom, we see value is Jacob is the best. So boom, we did it. So now we know how to actually get a reference to the whole NFT instead of being restricted by the NFT standard. Okay. Now, the last thing I want to go over, and this should take like literally 2 minutes, so I'm almost done, I promise. But what we're going to do now is make sure that, look, so right now in our collection, it's saying we're going to take in, so when we're depositing, we're taking in any NFT that abides by the standard. That's what this is saying. We don't want that. We want this collection to only store CryptoPoops, right? Because this is a collection for CryptoPoops. And so right now, if a Bored Ape wanted to be stored in this collection, it could, and that's not good. So what we can do is we can actually say, what we want to do is say let the CryptoPoop, what we're going to do is we're going to say, hey, take the token and force cast it to a reference to our NFT, and then move the CryptoPoop into here. And so what this does, CryptoPoop, what this does is this says, hey, we're going to take in any token that abides by the standard, but what we're going to do is we're going to say force cast it to a CryptoPoop. And so this makes sure that if we pass in a Bored Ape, for example, I keep saying Bored Ape. Bored Ape is like a NFT if you're not familiar with it. If we pass in like a Bored Ape, then what happens is it tries to force cast it and it'll panic here and it won't let you store it. So this is one way to ensure that we're actually storing NFTs from our collection. All right, I think that concludes everything. I know that was a lot. Oh, and we also forgot to do these. So we want to, when we withdraw, we're going to emit withdraw, and withdraw takes in an ID, which is withdraw ID, and it also takes in an address, which we can say self.owner. I believe this is how you do it. From. Okay, so when we emit the withdraw, we're going to say, hey, the thing we're withdrawing, remember, it takes in an ID, so it's the withdraw ID. And from, which collection are we doing it from? Well, resources have something called an owner. So wherever we can say self.owner, and that gets the current owner of this collection. So wherever this collection is stored in storage, it'll get that owner and then get their address. And so that's what that means. And then when we do deposit, we can also say emit deposit. And deposit takes in an ID and a address as well. So it's the exact same thing. UN64 and 2, is that what it's called? 2, yep, 2 self.owner dot address. All right, and I'm doing owner, question mark. I could also do this if I wanted to. Oh, oops. So crypto poop.id. Oh, well, it's saying it's already, let's actually just do this in between so that we still have access to it. So before we deposit it, we're going to emit this. I'm using this question mark. You can also use the force unwrap if you want. It's just because self.owner is an optional, so you can do whatever you want. But this is a fully working NFT contract, and of course, you could add anything else to your NFT if you want to. So, literally anything. So if you public let a tag if you wanted to, or anything, and you can put a bunch of other stuff. Now, I do want to mention also that NFT Minter is not a requirement. So this is something that if we got rid of this, of course it would complain here too, but this isn't a requirement. So you can decide how you want to mint NFTs all on your own. It's just that I happen to do this NFT Minter step. So that is NFTs in under an hour. I hope that wasn't too long, but there it is. Bam. All right. That is all I wanted to go over for today. And if you understand this, then you are pretty experienced in Cadence development. Hooray. I will see you in the next one.